This is our initial GUI. If we click on the training, it will ask whether to use the data or collect new. We click on collect new, and this is our collection procedure. After finishing the first activity collection, it runs a 3-second countdown and start a next activity collection. If we click on the stop collection, it just clear everything, and then we can start new. And if we return to the main application and then click on the training and use default training data and train the model, if we can get it shows the accuracy here. And we click on the testing, it will start testing. And after every 5 seconds collection, it will test our movement, our activities. And if we click on the test, it will start. It will stop. And if we click the test again, it will restart a new testing procedure. Since the cell phone running data viewing is quite slow, we run another demo on an emulator on another computer.
This is our 3D part. As you can see, when we click every label and the relevant chart will not show, and when we will click again, it will show again. And you can also achieve zoom in, zoom out, and rotate.
This is Shibing Zheng, and I'm mainly in charge of the whole application framework, including setting up all those variables we're going to use and creating the UI. For training part, we prompt a dialog on choosing whether to use default data or collect the new data if the user wants to. And then call SVM library so that we can derive our model. And for the testing part, we set up a timer for each testing collection and call prediction execution. So there is a tricky part. We can do a looping testing. Here is simply just call start. And every time on sensor changes, we also show the acceleration data on UI and collect data, testing data, and store them in cache so that we can predict upon that. I also write the utilities, creating the class we're going to use, and also the database helper so that we can store data into the database or extract from the database through SQL.
This is in here. I'm responsible for the data collection part. First, we will pop up an alert message to ask the user whether the user wants to use the default database or collecting new data. After receiving the confirmation from the user, we start collecting data. The collection process can be stopped at will. If the process was stopped in the middle, next time the whole collecting data process will restart from the very beginning. During the collection, we follow the order of the walking, running, and jumping. For each individual action, we collect 50 data points, and for each type of 3, we collect 20 actions.
My name is Shilu. I was doing the join 3D plot part. As you can see, we create the initial function to initialize the 3D plot for achieving relevant functions such as zoom in and zoom out, file access, and enable JavaScript. As you can see from here, we use the web view to achieve. We can use JavaScript to draw this plot, and in here we use HighCharts library to draw this 3D plot.
My name is Rongyue Cui from Group 24. My part is doing predict and power consumption. Here is the predict constructor. It will have the SD card pass and the delete model. In the train method, first we create the output path and stream. Next, we change the data format to SVM format. Here, the string has 3 parameters: cost, gamma, and k value. In the predict activity method, first we change the format and then we ran the prediction and generate a path string list. Then we run SVM predict and read the opt file to get activity type. Then I did the power consumption part. Here I draw the power and energy consumption plots for both testing and training.